Today, we're going to break down the absolute basics of one of the world's most powerful programming languages, C++. We're going to pull back the curtain and see exactly what it takes, starting from a completely blank file and building our way up to a program that actually does something. Let's get into it. You know, every single C++ program, doesn't matter if it's a simple calculator or a huge video game, it starts with the same foundational structure. It's kind of like a skeleton you can use for everything. So think of this as the non-negotiable blueprint for your house. That first line, the hashtag include bits/std C++h, is a super handy shortcut. It's like having every single tool you could ever possibly need delivered right to your worksite. Now, for bigger projects, you'd be more specific, but for learning, it's perfect. And that int main part, that's the front door. It's where all the action begins. So how do we get our program to actually do something? Well, to print some text out on the screen, we use a command called cout. It's short for character output. We just tell it what we want it to say right there inside the quotation marks. And boom, that's the result. It's that simple. What you type inside the code becomes the output on the screen. This is really your first step in making the computer do what you want it to. Okay. A program that only says hello is cool for a minute, but it's not very useful, right? To do any real work, it needs to be able to handle information. So let's look at how to store the ingredients for our code, the data. In C++, you have to put your data in the right kind of container. So int is for your standard whole numbers. But if you need to store a massive number, like in the billions, you'll need a long. It uses a bit more memory, but it can hold a way bigger value. For any decimals, you use double. For text, a string, and for just one single letter, a char. That's a fantastic question. You might be wondering, why can't I just have one big box for everything? And the answer really gets to the heart of what makes programming so powerful. It's all about efficiency. It really comes down to this. You wouldn't use a giant shipping container to mail a single letter, would you? The same logic applies right here. Using a long for a small number just wastes computer memory. Choosing the right data type makes your program faster, leaner, and more efficient. All right, so we've got our blueprint, and we've got our data containers. Now it's time to give our program a brain. It's time to add some logic, some decision-making power. And this is the classic if-else statement. I want you to think of it like a fork in the road for your code. The program checks a condition, in this case, is the age 18 or older? And then it performs a different action depending on whether the answer is yes or no. This is the main way programs make decisions. Now, what if you need to do something over and over again? Like, say, print your name 100 times. You're not going to write that code 100 times. This quote just perfectly captures the whole idea of loops. You let the computer do all that repetitive work for you. Exactly. Instead of writing the same command 500 times, you just put it inside something called a for loop. You basically tell the computer, hey, run this line of code 500 times, and it does it for you. It's automation at its most basic and most powerful level. So, as your programs get bigger, they can start to look like a tangled mess. They can get really hard to read. And that's where functions come in to save the day. Think of them like creating your own custom reusable tools for your programming toolbox. For example, instead of writing out the logic to add two numbers every single time you need to do it, you could just create a function and call it, say, calculate sum. Then, whenever you need to add numbers, you just call your custom tool. It makes your code so much cleaner, more readable, and way easier to manage. This is a really critical question, and it brings us to one of the most important concepts for any new programmer to wrap their head around. How do we actually get our information to these new tools we've just created? So here's the key difference, and it's a big one. Pass-by value is like giving your function a photocopy of your data. The function can scribble all over its copy, but your original document is totally safe. Pass-by reference, though, that's like handing over the original document itself. Any change the function makes is permanent. Understanding this is absolutely crucial. So, let's take a quick breath. We've just put together the fundamental building blocks of a C++ program. Let's just quickly recap what they are. With just these 4 core concepts, you really have the foundational map to understand how pretty much any computer program is built, from the simplest little script to the most complex software out there. And you know, that's what's so exciting about all this. Learning to code is really learning to create. You have the basic tools now. The only question left is, what are you going to build first? Thanks for joining me.